Fusion Mobile, quality e-learning experience on the go.
Welcome to Fusion Mobile e-learning clinic. My name is Sonia Lalo and I'll be walking you through the physics course. We want to consider general properties of fields. General properties of fields. And in this topic we'll be looking at the concept of a field. We'll look at gravitational field, electrical force and electrical field. We'll also consider the magnetic field and properties of electric lines. The properties of electric lines of forces. Of course, the electric lines of forces is created by the electric field. Alright, let's begin. What is a field? The concept of field was developed for certain phenomena in which they exert forces on objects. These agents in nature do actually exert a kind of force without having physical contact with the body they are exerting force on. An example of such a situation is that of the gravitational force, the magnetic force, even the electric force. If you check the gravitational field, nobody can actually point to gravity and say this is where gravity is pushing me down. But so long as you are in the earth, the gravitational force will ensure that you remain in a position where you are. In like manner, you cannot say this is the way in which a magnet is pushing or pulling a body until the body actually gets stuck to the magnet. The magnetic field attracts the body towards the magnet even without the magnet making physical contact with the body. The same thing can also be said of electrical force. Some people have been shocked. It actually do happen. You can be shocked by when you walk within the electrical grid. If the electric voltage at that particular time is up to a certain value. When you walk under certain electrical, that's why it is advised not to walk under high tension wires. And that's one of the reasons why high tension wires are kept at very high altitudes from human beings. It's not because they don't want them to touch them, it's because of the electrical force, electrical field which is around those wires. It is strong enough, it can actually electrocute without you touching the wire. I haven't spoken about the concept of fields. Some questions will pop up on your screen in a few seconds. Please do answer them. Welcome back. So, we've talked about fields and we've looked at how it operates. Somehow we're trying to relate to how it operates. But let's concentrate on gravitational field. We all know the gravity. We all know gravity, that is what keeps us, that's what makes everything that we throw off to come down. That's why when you jump up, you land back on your feet or on the floor. So, how does this work? How do these things work? What is the cause? Because for every field there must be something that induces the field. There must be something that creates it. Well, for gravity there is a law that was propounded by Isaac Newton, and he called it the universal law, but today is now being known as the gravitational law. The law states that the force of attraction between two bodies, M1 and M2, that's big M and small m, is inversely proportional to the square of the distance between them, and directly proportional to the product of their masses. This suggests that if we have the moon and the earth now, the force of attraction between the moon and the earth, let's call it Fg, equals the product of their masses, or rather is proportional, not equal now, it's proportional to the product of their masses. Let's say this is m for mass of the earth and m for mass of the moon, and inversely proportional to the square of the distance between them. So we'll call the distance between them r. So considering this, we can relate it, and we came up with Fg equals capital G m divided by r squared, where capital G is the gravitational constant. Now, for a body on the surface of the earth, of course, F is equals to mg, because of course force equals to mg, that is weight of the body, equals to mg. So the force of attraction attracting you to the earth is directly proportional, which is equal to gm m over r squared, while the capital M is the weight of the earth and the small m now applies to me as a person, my own individual weight. So if we want to find the relationship that exists between small g and capital G, where small g is acceleration due to gravity and capital G is the gravitational constant, then we can calculate that as g, or we can divide both sides, can divide m from both sides. We can divide m from both sides. Mg divided by m will be equal to gmm over r squared divided by m. M will cancel m, m will cancel l. So we have g equals to gm over r squared. We have g, that's acceleration due to gravity, equal to gm over r squared. The small g is acceleration due to gravity, the capital G is gravitational constant, the big M here is the mass of the earth, while r squared here, r here, is relating to the weight, the distance between the person and the earth's core. The distance between the person and the earth's core, that is the center of the earth. So if you want to calculate the kind of attraction, the attraction between the moon and the earth, of course you calculate from the center of the earth to the center of the moon, and you use that to do your calculation. That will give you actually the amount of gravity, the kind of gravity that is felt on the moon. For the electric field also work with the same kind of fields as the gravitational field. The law that bounds the gravitational field is also applicable to the electric field. The only difference there is, instead of us considering the masses of two objects, now we are considering the charges, we're considering two charges and the distance between the two charges. So we also have a constant. This constant, as it is, that's 1 over 4 pi EO, is taken as 9.05 times 10 raised to power 9 MF. Is known as the, so you can just apply this formula and solve when it comes to charges. The same thing also can be found in the magnetic field. The electric field now, this describes the force of the field, but the electric field itself is equal to, that is, the nature of the electric field is equal to the force of the electric field divided by the charge. That is, when you're talking about the amount of electric field force exerted by one of the charge, the electric field effect of one of the charge on the other, it can be calculated by calculating your electric field force and dividing by the charge from which it is being sourced. The magnetic field also works just the same way as all the other fields do operate. The interesting thing about magnetic field is we calculate the magnetic field strength. The magnetic field strength is calculated as B, which is given as V equals to V over Q V sine theta. B over F, that's the magnetic force that's the force of the magnet, divided by Q, which is the charge carried by the magnet, V, which is the velocity of the magnet, and sine theta, the theta is the angle between the B and the V. So magnetism, of course, has been studied over the years, and the knowledge of magnetism finds its application in the generation of electricity, in the development of machinery, different machines and tools. Even the knowledge of paramagnetism and others come from the knowledge that has been acquired from the basic magnets. Speaking of the properties of the electric lines of forces, the diagram on the screen shows you a couple of information. The first one you have there is the positively charged sheet. The positively charged sheet has the arrows pointing out, while the positively charged sphere has also one charge pointing out the arrow. Now the negatively charged sheet, of course, points inward, while the charged sphere, of course, has everything coming inward. Unlike poles, of course, for unlike poles, they say unlike poles attract while like poles repel. So while the positive is pointing out, the negative wants to come in. We have a positive and a negative. The positive is pumping out, while the negative is taking in. So they can relate one to the other, since this one is sending out and this one is taking in. Since this one is sending out and this one is taking in, this is a giver and this is a collector. But if we have two poles, let's say two positives, this one wants to give away. This one also wants to give away. That would result into a conflict. Both of them cannot connect with each other, so they will repel each other. This principle apply not only they would repel each other, but these ones they would attract each other. This principle not only applies in electric circuits or electric system of forces, it also applies in magnetism. And that's why we come up with the idea of like poles attract, unlike poles repel. So in this lesson, we'll consider the general properties of fields. We looked at the concept of field. That is, a field is not something that's common to all situations, but it's only for some selected phenomena, like in magnetism, in gravitation, in electricity, that we do have fields come up. It's not all things that have fields. Most forces do not exist in field form. They exist in contact forces form. We talked about gravitational field, where we talked about the Newton's law of gravitation, which says that when two bodies are acting on each other, the force of attraction between two bodies moving about each other is indirectly proportional, is inversely proportional to the square of the distance between them, and directly proportional to the product of their masses. This law is also applicable in forces, in electric forces and electric fields, only that you switch masses for charges, and you switch G, which is the gravitational constant, for your electrical constant. Also in magnetism, it is also applicable. We consider the strength of magnets to be calculated as the force of the magnet divided by the product of the charge of the magnet and velocity of attraction, and the sine of the angle between the magnet and the point of the attracted object. That's the field, in the field. We also consider the properties of electric lines of forces. We spoke about the positive sheet, which has horizontal lines of action. We talked about the positive sphere, which has a sphere radiating light, ready to give out electrons or charges. We also spoke about the negative charges, which are horizontal lines of receiving, or the sphere ones, which have circle and lines radiating towards, that is inward, the sphere. I haven't spoken about this. In a few seconds, some questions will pop up on your screen. Please answer them, and if you have any inquiry, any confusion, you can go over the topic once again.